All right, let's take a look at problem number 2 for MATLAB's last octave module 4. So problem number 2 has you generating a table of conversions with 4 columns. So you're going to have US dollars in the first column, and you're going to have Japanese yen, euros, and British pounds. So what this program is going to do is it's going to ask for each conversion factor. Right? They're not the same. It's not the same conversion factor between dollars, yen, euros, and pounds. So it should ask for each one of the conversion factors. Then it should use those to do the calculations. The table is should contain or shall contain 51 values. It's going to start at $1 and go up to 500. 51 total values. So if we take a look at the code that I have here, again, this is an octave. You notice that I've got my comments at the beginning here. So we know this is problem 2 from module 4. It's conversion from dollars to yen, euros, and pounds. So you got my name. So as we go down, right, the first line of code is setting up the matrix for my dollar value. So there's a little trick to this one. First off, I asked you to have $1 and then 50 values between up to 500. So if you start with 0, you're not going to get 1, right? So what I've done here is I'm putting the value 1 in my matrix first. Then I'm going from 10 to 500 by 10s, which will give me the 50 values. So I got the 1 value, and then I've got my 50 values. So a little bit of a trick. There's probably other ways to do it, but that's the best way I found to do it. Then I have my 3 inputs, right? How many yens? What's the conversion factor for yens per dollar? How many euros? How many pounds? So asks for those 3 conversion factors, assigns those values, applies those conversion factors to the yens, pounds, and dollars. Again, remember that dollar is a matrix. We want to combine that. We want to apply that to each value, hence the period, so that we get element by element rather than matrix by matrix operations. I've got my fprintf command, so the first one gives me the title for my table. The second one gives me my headings, and then the third one is going to provide the output values. Now, I mentioned in the first video that Octave is terrible at formatting when you get to 4 columns, and you'll see that in a moment. In theory, right, you can see that I've got my tabs should line everything up, but we're going to see in practice that's not true. We're going to see that there's kind of an invisible page break thing that screws you up here in Octave. But the machine that I have MATLAB on, for a technical reason I can't make videos on, this would look much neater in MATLAB. So sorry about that, but you're going to see what happens. So let's run the program. So we run the program, and we flip over here to the command window. And oops, I forgot to clear all of the crap to begin with. But you can see here the program's run. How many yen per US dollar? Well, what I like to do, just to kind of keep things simple, we'll put in a value of 2, 3, and 4. So the first value will be multiplied, the second column will be multiplied by 2, the one, but the next one will be 3 and 4. And we're going to see that's pretty good. You can see what happens to the formatting here. That there's like this invisible page break. So if I move this over, you can see it looks like nothing's there. But so that's kind of what happens with Octave. I'm not quite sure why. But if we look at the first few, things look okay, and we can take a look at what's happening. So right, there's 1, and then you got 10, and you can see all the way down to 500. So there's the 50 is 10 through 500, and the 1 value. Right, you can see 2, 3, 4. Right, remember I put in the conversion values of 2, 3, and 4, so you can see that, and you can see the same thing with 10. Right, 10, 20, 30, 40, and that goes all the way down through this. And again, this formatting, if you ran this in MATLAB, you would see the formatting is nice and clean, but you got this crazy invisible page break here that screws you up. And I've tried everything, and if somebody's got a tip that can fix this invisible page break, let me know, because I haven't been able to figure that out. So there you go. there is converting or creating a table with 4 columns in Octave. It looks much cleaner in MATLAB, but that's what you're going to get in Octave.